Welcome to the Joe Rogan Recap. In a recent, absolutely mind-bending conversation, Joe Rogan sat down with astrophysicist David Kipping. And let me tell you, it was a journey. For this explainer, we've distilled that epic chat, a real deep dive into the cosmos, tackling the biggest questions you can possibly ask about the universe, our place in it, and of course, whether or not we're alone.
Okay, so here's how we're going to break this down. We've structured it as a kind of cosmic zoom out. We'll start with the puzzles that are driving astronomers crazy right now, and then we'll keep zooming out, all the way to humanity's truly wild and unique moment in the 13.8 billion year history of everything.
So first up, we've got to talk about the James Webb Space Telescope. This thing unfolds in space, a miracle in itself, and starts pointing at the darkest, most ancient parts of the universe. And almost immediately, it starts finding things that, well, according to all our theories, just shouldn't be there yet. And as David Kipping said, astronomers were just floored. I mean, it wasn't just that the telescope worked, but the quality of the data it sent back was beyond their wildest dreams. It's like we've been looking at the universe through foggy glasses this whole time, and someone finally handed us a crystal clear pair.
So here's the deal. Our theories predicted that the early universe would be this slow, gradual buildup. You know, little baby galaxies forming over time. Instead, Webb found these huge, mature galaxies that Kipping called suspiciously too old. And even crazier, it found supermassive black holes that were growing faster than physics should even allow. They were basically breaking the cosmic speed limit for how fast a black hole can eat.
Now you might be wondering, how do we even know how old this stuff is? Well, the key is this thing called redshift. As the universe expands, light traveling across it gets stretched out, kind of like a rubber band. This stretching shifts the light towards the red end of the spectrum. So the more red-shifted something is, the longer its light has been traveling and the further back in time we're looking. It's the universe's own built-in time machine. And this whole puzzle with the James Webb Telescope, it plugs directly into an even bigger problem. A problem that's been bubbling under the surface of cosmology for years now. They call it the Hubble tension, and it's a real crisis.
The whole crisis, this huge debate, it boils down to this one simple-sounding question. For decades, we thought we had a pretty solid number for how fast the universe is expanding. It's called the Hubble constant. But it turns out, how you measure it completely changes the answer you get.
See, we've got two gold standard ways of measuring this. One method looks way back at the afterglow of the Big Bang and uses our best model of the universe to predict how fast it should be expanding today. The other method looks at our local neighborhood, nearby stars, and measures how fast they're actually moving away from us. And the problem? The two numbers don't match at all. Our little corner of the universe seems to be expanding faster than our big picture theories say it should. And just to be clear, we're not talking about a small rounding error. The disagreement has hit what scientists call a 5 sigma confidence level. Now, what does that mean? It means the odds of this just being a random fluke are less than 1 in a million. So, yeah, this is real. And it means something is fundamentally wrong with either our measurements or our entire understanding of the cosmos.
All right, let's do our next zoom out. This theme of our expectations just getting completely shattered continues when we look at planets around other stars. Our search for exoplanets has totally upended what we thought a normal solar system was supposed to look like.
For the longest time, we just assumed most other solar systems would look like ours, right? Small rocky planets on the inside, big gas giants on the outside. But then we started actually finding them. And oh boy, the data revealed this absolute zoo of bizarre alien worlds. But the biggest surprise of all was an entire class of planet that seems to be the most common type out there.
And that's the punchline right there. These planets are called mini-Neptunes, and they are everywhere. As Kipping points out, this is one of the strangest discoveries in modern astronomy. The most common type of planet in the entire galaxy is completely missing from our own solar system. It turns out we're the oddballs. We're the weird ones.
Okay, so if planets are actually super common, and our solar system is the weirdo, that leads us to the next and maybe the most profound zoom out. It leads us to one of the most unsettling questions of all time.
We now know for a fact that planets aren't rare. They are the rule. Kipping says that on average, every single star you see twinkling in the night sky has at least one planet. It's actually harder for a star not to form planets. They're just everywhere.
And that simple fact sets up the famous Fermi paradox. With hundreds of billions of stars, most with planets, and with 13 billion years for something to happen, the universe should be absolutely teeming with life. And you'd think at least some of it would be technological and obvious. But when we point our telescopes out there and listen, all we hear is silence.
And believe me, scientists have imagined all sorts of insane techno-signatures we could look for. I'm talking massive spheres built around stars to capture all their energy, or giant structures sending signals across the galaxy. But we look and we see nothing. As Kipping says, as far as we can tell, the universe appears 100% natural. And that is just mind-blowing.
And that great, eerie silence, it brings the focus of our final zoom out right back home. Back to us, here on this tiny blue dot at this specific moment in cosmic history. What does it all mean for us?
When you really look at the timeline of the universe, you realize just how unbelievably new we are to the game. The universe has been around for 13.8 billion years, Earth for about 4.5 billion. But complex life, like animals, that's only been around for about 600 million years. And us? Human civilization? We are a tiny, fragile, almost invisible sliver at the very, very end of that timeline.
So we're left with this incredibly provocative final thought from David Kipping. Maybe we are totally alone. Or, option 2, maybe we're just really, really early to the cosmic party. But then, he offers this third, wild possibility. Maybe we're just the next intelligent species to show up on a planet that still has 1 billion years of life left on its clock. And if that's true, the most likely alien we'll ever meet might be from a future civilization right here on Earth, which leaves you wondering, what message would you even want to leave them?